So yeah, I'm James Alexander. I'm a digital library developer at the Open University, and I'm presenting today on the Open University's Fedora migration. So this is a migration in two ways. It's a migration from 3 to 6, and it's also a migration from on-premise architecture to in the cloud. Although the solution is relatively similar in the cloud. We're not changing out our environments, right? So this is Rosie, my cat. So that's also one for the bingo card. And like me, she also occasionally, although I usually regularly attend the weekly tech meetings. In fact, she's secretly here today, but I can't show her at the moment. So I'd say I'm a developer, but not really a Fedora committer. And also for the past couple of years, I've been on the Fedora governance group, which has been a very interesting and pleasant experience. So I'd recommend it. So what to expect today? Really, this is just a kind of roundup and progress of our cloud migration uh, from 3 to 6. So where we started from, and some other things of interest, I hope, along the way. It's difficult to know exactly how to pitch this because we're all probably from slightly different backgrounds. But yeah, this is really the story of our cloud migration to date. So yeah, the Open University Digital Archive has been running since about 2012. They're sort of intertwined sites. One is a staff-only site, which has some complex rights issues, and the other one is a public-facing site with open content and lots of metadata records. So, oh yeah, and there's an administrative backend as well, which we use for administering both Fedora and the websites. So that's a screenshot of it. So yeah, the archive has a wide variety of content. The main thing is that it's really our own teaching materials generated by the Open University, and much of it was also created in partnership with the BBC, that's the British Broadcasting Company, over the years. And as well as public access, staff access is really important to us, particularly since the site is quite heavily used for, reused for course production. So yeah, quite a lot of staff usage there. And this is a kind of pencil outline of our plan. It's not the actual plan because the actual plan runs to pages and pages, as you can imagine, for the Open University. But yeah, so this is the kind of the short version. And so we've gone through the first part of that, which is to agree a plan for cloud-based services and implement these infrastructure as code. So, and then we're into the second part of this. So the easy bit was running the migration utilities to transfer the content onto OCFL. That really took only a couple of hours, I think, because our repository isn't large, but I'll come on to that. So now we're currently creating lots of custom XSLT to migrate what have become binary metadata files to create RDF records using our custom profiles. And then we've got quite a long way to go. And like for most people, a lot of the problem is really juggling the kind of business as usual and also actually getting through the migration. So we're kind of expecting to do some parallel processes with upload of kind of high resolution files, but we probably won't. We kind of deprioritize that because it's such a lengthy process, and we don't want to get distracted from doing the kind of the main work that we need to get done in order to launch the public site and retire the existing infrastructure. So this is our current, or well, I should say it's current, but it's also pre-migration infrastructure. Streaming media server shouldn't really be there. We've kind of done away with that sort of virtual streaming, sort of using virtual streaming. So you can see that it's quite heavily spec'd. We've got load balancers for our application servers. We've got load balancers for our web servers. We've got a MySQL database. The other thing that this kind of doesn't really show is that we've got loads of offline storage. So we've got about more than 200 hard drives with about 200 or so terabytes of high resolution audio and video that currently we want to get ingested onto the cloud. And our infrastructure summary is really that we're the Fedora base, but we have a custom PHP front end, and we have a heavily customized Solar install. So this is kind of a bit like Blacklight to kind of aid with the search and findability. So as you probably gather from the previous diagram, the Open University Technical Architecture is kind of generally goes for quite heavily spec architecture. But to be honest, our repository is not at all large by most measures. In fact, the internal data probably doesn't amount to more than 100 gigabytes of files uh, on the system. We've got just under 200,000 objects, but how do you measure an object? It's kind of, I'd say there's a kind of 200,000 logical objects. We've got a lot of files that aren't inside Fedora, a lot of ones that uh, are externally linked, and quite a lot that we just have metadata records for at the moment. So the site is well used internally and also publicly, but I wouldn't say it's ever under heavy load. And if you look at our infrastructure, we've got we've got the full three environments here: live, acceptance, and development. Obviously live is up 24/7, but the other environments are kind of quite uh, lightly used, I would say. The acceptance environments in particular is really only used, perhaps once a week, once a month. We don't have a lot of developers; they're just the two of us, and it's a complete replication of the live infrastructure. So it's quite a lot of spec for perhaps not such a large and complicated site. So, I mean, I think I could probably skip through most of the why we went to the cloud because I think it's what everybody's doing. But I'd just say that we were both pushed because, that's what our internal IT department would like us to do. They find the shared responsibility of kind of looking after environments and applications, how to portion it out, something somewhat problematic. And also the archive was lured by the prospect of being able to secure a kind of long-term home for the 200 terabytes or so of material that are on hard drives that are kind of aging. So yeah, there are pros and cons really. We're kind of hoping that we might save a bit of money on the infrastructure because we don't expect to use quite as much kit as we're currently doing. But it probably won't be cheaper because the storage will doubtless far outweigh that. So I kind of skipped through the reasons why we're using infrastructure as code. I mean, really, it's just because probably everybody using Fedora is going to do that because the environments are relatively complex. And you need to, if you're particularly if you've got three environments, you need to be able to reproduce them exactly. So moving on to some of the tools that we find useful, I just kind of briefly highlight that this is our current Internet as Code tool set. So we're using Terraform, GitLab really mainly for version control, and Brainboard as a kind of GUI interface to Terraform. I'll say a bit more about that. We could probably equally well have chosen many other combinations: Polami, TypeScript, and Git, CloudFormation, Python, TypeScript, and I don't know, version control tool of choice. But for us, the Terraform's scripted approach was kind of fairly intuitive and a kind of low barrier to entry, which was really useful for us since we're not cloud architects. And that together with its, well, I say we're not cloud architects, but we've spent a lot of the past year doing that work. So together with its widespread adoption and platform agnostic way of running, we kind of felt that Terraform was a good fit for us. And if you're not familiar with Terraform, this is just a list of kind of like useful resources. So HashiCorp, which is the kind of the home for Terraform. I mean, there's also OpenTofu, which is an open source version of it. Has excellent resources and brilliant documentation. But a resource I particularly like to draw your attention to is that there is actually a complete Fedora deployment on using Elastic Beanstalk in somewhere in the on the Lyrasis website in GitHub, which is kind of interesting and quite useful. It needs some updating, but it's a useful way to start. Yeah, there's just lots of material out there about Terraform that's really, really helpful. So I'll say a bit more about Brainboard because you're probably less likely to be familiar with that. So it's if you've never heard of it, it's a GUI application for creating cloud infrastructure using Terraform. And so the template library they have is a great place to start because it just kind of helps you, and it has many features. I'd say it's a really great tool. And once we'd created a couple of environments using just Terraform, we found it really helped speed up our learning process, and it has, so many features. So this is kind of I'll just show you a screenshot of what it looks like. Yeah, so this is kind of a view of Brainboard design interface. It has another interface for CI/CD, but this is the one that, so you can see that on the, perhaps you can't see, but I can see on the left, there are kind of Terraform resources you can drag and drop onto the main architectural diagram board, which is in the middle. And then on the right of that, you get a view of the code that's being generated by the things you've dragged and dropped, and you can edit those. It's kind of pretty intuitive, but it packs a lot in. There's an awful lot of intricacy to using it, as well as the kind of intuitive look and feel to it. So, I mean, we've only just started to dig into the other interface, the continuous integration, CI/CD, and continuous deployment interface. But it enables you to kind of create a pipeline workflows, so you can do cost estimation, and you can kind of like have code audit and approval processes, and you can do this in a drag and drop way, which is just unlike anything else, I'd say. And perhaps the most useful part of the tool, the most useful part probably is that you can kind of do version control in it without doing anything more than clicking the button. I don't know if you can see it there in the middle there. There's a kind of little button that's a clock, and that basically will produce snapshots of your current infrastructure. So another useful feature is that if you use it, you can use it to maintain your record of Terraform state, which if you use Terraform, kind of you'll know can be a bit of a headache. And it has other great features like being able to separate out the variables into different environments, which is kind of something you don't get for standard. Yeah, I mean, I'd thoroughly recommend it, and I'm not on commission. So this is a view of our current architecture. You can see there comes a point at which it gets quite complicated, really, to understand and to see. But the things are broken down into regions. So on the top right-hand side, you can see what we're running in the, I think it's in the East US region, and that's our CloudFront deployment. And then most of the est is deployed in the London region, as you might expect. It's an infrastructure. It's probably easier to show it using the simplified version, but that's just kind of a look at kind of the sort of interface you can expect to generate from that. Inevitably, once you start developing things, a lot of what you get is based around role-based permissions, which doesn't really help for the display. So this is what we've actually got. Yeah, CloudFront cache, Elastic Beanstalk, and Fargate containers. I probably won't go into too much detail because I see I'm kind of already squeezing myself on time. So just to say that it's been relatively easy to set up with the architecture we've got, and perhaps to highlight that Elastic Beanstalk might not be the way to go for most people because it's relatively complicated. But for us, it's good because it means we're not maintaining the environments, and that's kind of one of the things we were kind of set on not doing. So, and if you're running fixity checks, we found that you can do these without moving the objects in service, and this is way cheaper than moving them out and doing the fixity checks and replacing them in your archive. So, yeah, I don't really have time to go through this custom development stuff, but really it's like the other custom development things you've heard on, but where the people are developing Solar records. So this is really about enhancing our Solar search records. I mean, I could probably skip through this stages of this, but really what it amounts to is that we get information from Fedora into the endpoints to the endpoint service, and then the endpoint service makes up a more complicated record to send to Solar. So I'd say that when we were developing this, one thing we quickly found was the need to create a kind of like a thorough log of the headers and messages we received and sent. And once we'd done this, we found it so useful that it gave us the idea to solve another problem that we would also got. So the problem is that Solr is quite a stateful service, and in the cloud, this is a bad thing, since it makes it difficult to swap out and replicate the service, particularly dynamically. So what we have in mind to do is to use this to create a journaling service. So that will be a bit like Fedora 3 replication, which could be or like a database replication service, which could be used to play back and play forward a service to update the index. So that's one idea we like the sound of, and we're using some of the kind of newer features of Solr to the enhanced permissions, so that, for example, our PHP front end will have read-only permissions on search, which kind of is a security measure that Solr has been lacking for years. And that's really my presentation, I think. Really, if there are any questions, I'm happy to take those.